Hi, welcome to Project Geospatial. I'm Adam Simmons, and I'm here with Kleos Space as they partnered with Virginia Tech on an amazing project that they're going to talk about today. Here with me to talk about that project is Karyn Hayes-Ryan, who's the director of Kleos Space Inc., the U.S. subsidiary of Kleos Space, and Guillermo Gutierrez, the product manager at Clios. Both of you, what's going on with this project? And I can't wait to learn more.
So Clios is always looking for new talent, new ideas, as a new company. And one of the thoughts that we had was to reach out to college students to have them create things rather than us driving the initiatives, but sometimes to receive them. So we have two students from Virginia Tech, Andrew Robinson and Avni Singh, who participated in the internship throughout their fall semester, concluding around the new year, with a project they have done for us. Andrew and Avni will talk a little bit about that. So first, how and why did you two both select Virginia Tech?
I actually didn't formally tour Virginia Tech in high school, but what really drew me to Tech was the way that students would describe the campus and the Hokie community. So I didn't end up going right out of high school, and I went to George Mason for mechanical engineering, but I always knew Tech was where I wanted to end up. So I put in a transfer application as soon as I could, and now I'm in my third year in aerospace engineering at Tech.
Yeah, for me, I can say I was one of those kids in high school that just really loved physics. I knew Virginia Tech was always a place that people would talk about. It's a great place for engineering and science. So it would just be a really cool place to get involved with cool projects. So I applied as a physics major. And I was considering the switch later on, but my interests were kind of floating around things like nuclear physics and particle physics at the time. So when I was a sophomore, I didn't really want to move on because I just liked how I was able to explore all the variety that Virginia Tech has to offer.
Yeah, there's definitely a lot of support for the engineering and science aspects here at Tech. So especially in the engineering department, since we're on a design team, we've been able to experience how the department supports its students. And we get a lot of opportunities to apply concepts that we're learning in class and lab to actual industry applications. And the department does a lot to make sure that the teams are getting what they need to make sure that they can pursue different avenues of applying their classroom experiences to real world applications.
Great. And speaking of real world applications, what got you interested in between all the different science and engineering careers and opportunities out there? What got you interested specifically in the aerospace industry? Avni.
I think OLVT was definitely the primary factor for me. Meeting all the older people with a background in the industry that were getting all these cool job offers and internships from places like SpaceX or Aerojet Rocketdyne or Northrop Grumman. I would say another influence was definitely working with Clios this past semester. I was able to see the approach to a lot of complicated problems in the geospatial industry with these real applications. So it definitely allowed me to use my physics background with things like forces, thermal, and mechanics that I was learning in class. And then on top of that, it's just really cool to be a part of a growing industry with a lot of influential repercussions.
I actually grew up watching Star Trek, so I was always fascinated by the concept of space travel and warp speed, and I feel like I really resonate with that quote that goes, born too late to explore the seas and born too early to explore the stars, because I really doubt anyone's going to be making any breakthroughs in warp drive anytime soon, but the least I can do is build rockets that'll send cool things to space. So I've also always really been fascinated by the possibility of extraterrestrial life, and as a kid I grew up watching those conspiracy documentaries where they talk about alien life on other planets, so hopefully I can contribute to that in some small way during my lifetime.
That's great. One of the groups that you belong in to Virginia Tech is called OLVT, and I'd be very interested to know what is the purpose of that team. What kind of vehicles have you built? What is the design process, the challenge, and what are your roles?
So OLVT is the Orbital Launch Vehicle team at Virginia Tech. So what sets us apart from the other teams is rather than being competition-based, we mostly operate with the main goal of reducing the cost of student payloads to low Earth orbit.
Yeah, so like Avni was saying, OLVT is a design team that has a huge impact on students by introducing them to these problems that teach the basic principles of manufacturing, testing, and then aerospace design. So on the team, we have to educate every member to the full extent of the launch vehicle design. In order to do that, we split up the work in these engineering sub-teams that are specialized just to control these different aspects of the process. And then on every Sunday, we come together with all the sub-teams to get together and form a more solid understanding of systems engineering with the major project in mind.
So as for roles, I'm the lead for the structure sub-team, which is responsible for mostly the manufacturing of parts, the design of recovery system, and analysis of the different forces that will act on the vehicle during its trajectory. And the main goal is to make sure that we don't have any structural failures and to design our vehicles to make sure that they have a factor of safety with every component. And the structures team, in my opinion, is especially important because we really drive the design by getting each sub-team's requirements and using them to determine what our launch vehicle is really going to look like and what it'll do. So things like the dimensions of our body tubes, the weight of the total vehicle, and just making sure all of the parts fit together. So really the most important part of the design process is that it's iterative, and we try to employ a lot of systems engineering. So we build on what we learn, and we're making sure that with every iteration, we're getting closer to presenting the best design possible based on our requirements.
So I'm also on the structures team with Avni as a recovery engineer for, a little over, probably just under 2 years now. So I'm responsible for creating and testing all the parachute deployment systems for the launch vehicles, including shock cords, eye bolts, parachutes. And in the past, I've worked with a lot of black powder charges and CO2 peregrine systems that are joined to all the onboard avionics. So there's a little bit of electronics involved. Now, more recently, I've been involved with the manufacturing process for designing things like body tubes, fins, motor mounts, and we just use a lot of CAD and 3D printers for that. So it's been a cool change this semester to do everything in-house.
Yeah, so far OLVT has successfully designed and launched 3 vehicles. We're currently working on a vehicle called Skipper 1, which is named after one of the cannons here at Virginia Tech that the Corps uses. And Skipper 1 will mostly be used to test new propulsion, recovery, and avionics systems. So one of our main goals for the structures team with Skipper 1 is to manufacture as many of the components in-house as possible, just so we gain experience with things we can apply to future careers like 3D printing, composite layups, and just general machining. So there's definitely a lot of challenges that come along with the design process of coming up with a whole new vehicle. And especially since our team is student run, we don't have competition requirements to guide us or requirements for professors, but we do have professors on our design review board that we can go to with questions and make sure that the paths that we're on for our design process are the right ones, or they can give us any insight as to what they've experienced in the industry, or all of them are also into model rocketry, so they also have a lot of experience with flying vehicles that are similar to the ones we're designing. So they're definitely a good source of inspiration and justification for our design choices.
Changing gears a little bit. This fall semester, what's got you interested in Clios?
Yeah, so with the Clios opportunity, I definitely wanted to see the other side of the engineering process. I know Avni and I have spent a lot of time, especially on the team, thinking about payload delivery, but we never actually get to see the utility of the payload itself. So Clios had this great opportunity to get involved with the operation and maintenance of satellites, which is a growing interest of mine, because I guess the big thing that made me interested in Clios was the approach with the radio frequency. Instead of your standard AIS tracking that a lot of other space surveillance companies use, I guess the fact that they were working with a lot of ocean surveillance also set them apart and gave all these diverse applications for their contracts. And then also the size of the company was really intriguing as well, because a smaller company definitely allows for more exposure to experienced people that I was able to work with in this internship, and they're just always there for questions if you need anything.
For me, since Clios has a new satellite cluster launch coming up, I was intrigued by the idea of contributing to the whole process of optimizing the coverage of the satellites based on different customer needs. So I was actually the testing lead for a CubeSat design team in high school that didn't end up launching. So it was cool to apply what I'd learned through that team to a real world application. And especially since I was able to see how Clios caters their satellites to a lot of different applications, I was able to take what I learned there and think about it in different ways and think outside of the box versus what I thought about with satellites before.
Great.
Thank you. Thank you very much. Kleos very much appreciated what you've done for us. So a little bit to follow on with that, a technical question about the work that you've done. It's a multi-part question. So how did you approach the problem and what methodology did you use? How did you divide the work between the two of you? And wrap up with what new skill set did you develop or a skill set that you already had that you optimized?
So we were asked to create a satellite cluster that would optimize revisit frequency and coverage times of a couple of key areas of interest that we later narrowed down to China, the Middle East, and Russia.
Yeah, so to split the project, we had to do it in a few ways. The first part was definitely to establish all the areas of interest over the major bodies of water, which is what Clios is more concentrated over with their RF approach. We targeted all the South China Seas. We targeted the South China Sea, and we centered our Middle East target over Iraq because of its unique location between the Persian Gulf, the Red Sea, and then the Mediterranean Sea. And then we did Russia over Moscow, just to include a small strip of that Baltic Sea as well.
Once we had our areas of interest narrowed down, the next part was pretty much to just run the trade studies and SDK on the active Clio satellites to see their current coverage. Once we had those trade studies figured out and we'd learned how to use SDK, we had to find different orbital qualities for surveillance over the areas of interest through those trade studies.
Yeah, and when we were iterating through those orbital qualities, we're trying to optimize the revisit frequency and the coverage over those areas of interest. So we used those qualities from before and then built constellations and collected data on those exact frequencies and organized it all into a report.
Yeah, once we were done with the trade studies, all we really had to do was kind of polish it up and put it into a presentable format. So we've had experience on OLVT before with formal presentations and writing papers, so that definitely paid off, and we were able to put something together with good figures and tables to send off to Karyn and Guillermo to look at.
And then as far as dividing the work, Avni and I kind of came together to select the phases of the areas of interest that we were going to look at. And then once we had those set, I did a lot of the trade studies to collect the data for all the active and the new constellation data.
Once we'd established the areas of interest and Drew ran the trade studies, I went back and looked at the data from the studies to look at the revisit time and the total coverage between each time a satellite would pass over one of the areas. So once we had all of that completed, it was mostly just focusing on putting the presentation together to send.
I guess as far as the growth for this project, it's important to note that I really did not know anything about geospatial satellite surveillance before this project. So the first few days I had a huge learning curve with trying to learn all the jargon that the space industry uses, things like inclination, right ascension node. So it was definitely more complicated than I anticipated at first. But I also completely learned how to model satellites and take data on their activity in SDK. So it was a huge learning experience for me.
In terms of soft skills, like I said before, Drew and I have had practice with presenting documents to our team advisors through OLVT. But this internship was a little different because we had to learn how to communicate with actual professionals in the industry, and there were slightly more, repercussions that come along with speaking to professionals versus just presenting to a professor that's part of your design review board. So for me personally, I also was able to develop better time management skills. Last fall, I had a full class schedule on top of being a lead for a design team. So it was definitely a struggle in the beginning to balance all the work, but I eventually got a hang of it, and Drew and I got into a good schedule of how to manage the workload.
That's wonderful.
Yeah, thank you. And it was a very well written, well organized, and thought out report as far as the sections and how it was presented. So that was really great. Diving a little more into the geospatial challenge that you faced, particularly Drew, but also Avni, linked to the AOIs. How easy or was there a steep learning curve? How easy was it to moving back and forth between the different geospatial frames of reference? Because in space we talk about Earth center, Earth fixed coordinate systems. As you're scanning over the ground, you're talking about really latitude, longitude based and elevation coordinate systems that are more ground based on the ground. So was there any particular challenges you had to overcome in that regard?
Yeah, so coming into it, I guess imagining all the scenarios in your head is definitely not easy. I remember thinking of satellites as kind of a simple system. You just kind of launch it up there and it goes around the world, but that is not the case at all. There are so many things that are moving in this system. It becomes far more complicated than I had imagined at first. So I guess in terms of reference frames, STK definitely made it easier to understand with a kind of a visual system where you could see everything play out in front of you. Both points of reference just became a whole lot easier when you're using a program to do the visual imagery of it in front of you. But it definitely was complicated, that's for sure.
Yeah, I took astromechanics last semester, so concurrently with the internship, I was learning about the basic understanding of different reference frames and the different factors that like right ascension node and stuff like that Drew was talking about. But I hadn't really had the opportunity to apply those concepts yet. And like Drew was saying, SDK definitely made it easy to look at. I'm definitely a visual learner, so being able to look at the different orbits and coordinate systems made it easy to see how the different pieces fit together. And even though you have so many moving parts, you see how they move in relation to one another, and you can really break it down into simpler steps to look at.
Andrew and Avni, this was a wonderful experience for Clios. You're our first interns, and we definitely want to continue along that path. So we really appreciate all you've done. I think it is really important for the audience at Project Geospatial to see not just what capabilities companies have, but the path as the students are growing to enter into the geospatial and aerospace industries.
Thanks, Karyn. Thanks, Guillermo, and thanks Avni and Andrew at Virginia Tech. I think that was an excellent overview of the project that both organizations work together on. To cap the conversation off, I have a few questions of my own to follow up. So for both of you, let's start with both of you here for a second. How different, and Andrew, you touched on this just a little bit, but let's start with you, Avni. How different is your perspective of the geospatial industry before you started this project and now afterward? How open is your mind to the opportunities that are available to you than you had before?
So I worked with remote sensing in the past through the CAP program, which is the Science Engineering Apprenticeship Program. So through that program, I got to work at an internship at the Naval Research Laboratory right out of high school. And while I was there, I worked on a project that had to do with solar flares. But most of the project was, creating and running Python scripts to clean data that had already been collected. So it was cool to be a lot more hands-on and solve a problem from scratch, rather than being given data and told what to do. We were able to actually figure out ourselves what path we were going to take with the problem that we were given, and then run the actual trade studies, learn the software to do it, and come up with a report at the end. So I'm definitely a lot more open to opportunities in the industry now, just because I see that there's a lot more applications than I had initially thought. So it's definitely something that I would consider exploring more in the future.
Go for it, Andrew.
Yeah, no. So for me, I guess I didn't have the kind of exposure to this industry when I was, earlier on in my undergrad, and it's something that I just got exposed to now. I definitely think that this is something that I would want to do more. It's very interesting, and I just want to be able to solve these problems that the geospatial industry has exposed me to. And I've gotten a lot of more appreciation and just respect for the people working here. So given the opportunity, I would definitely love to learn more and continue working with these kinds of problems.
Well, that's a good follow-up question. With as much experience as you built up, both of you have built up doing this project, as well as the experience you've built up being in Virginia Tech, what would be your ideal starting role upon graduation? Start with you, Avni.
Sure. So for me personally, I've figured out that what I like to do is to really apply concepts that I've learned in classes to real design experience. So I love a position where I can basically continue doing what I've been doing on OLVT and doing analysis of suborbital and orbital launch vehicles. And through this internship experience, I definitely have a much better idea of how these vehicles can work with the satellites that they're inserting into orbit and what those satellites can do. So really a role where I can work on both aspects of both the launch vehicle design and the satellite design would be perfect. And just being able to lead a team. I figured out recently that I do like being in a leadership position and, kind of guiding students as they're working on projects. So I'd love to have a leadership role where I can oversee the design of those things and send something cool to space, which is what I've been wanting to do as a kid.
Yeah. I think to combine some of the skills that I've learned from this particular internship and then all the stuff that we do here on OLVT, I've been trying to apply to things like satellite engineering positions just to get more experience in designing and continuing to learn more about surveillance. I'm also applying for manufacturing engineering positions just because I still like to work with hardware and just be able to design and I guess bring those designs to life and integrate it into a larger system. So all these new positions are pretty exciting, I guess.
Awesome. Well, thank you both for answering those questions. Karyn, Guillermo, I actually have one or two questions for yourself. In terms of the data that Avni and Andrew worked on, what's the aftermath of that? What happens after that project? What's the transition of them working on it, and what are you going to do with it?
So as we looked at their studies of optimal orbits at Clios, we're definitely looking to optimize our orbits for our customers' requirements. So to look and see which ones are going to provide more data in crisis areas, in critical areas. I think that is going to provide us with an overall constellation capability because of the opportunities to revisit, look at certain geographical areas multiple times a day, depending upon the crisis. I'm meant to be able to do a monitor type activity where you see something once or twice a day. Guillermo?
Yeah, and I'd just like to add that not just in the end results, but the actual process and the methodology presented gives us basically additional arsenal of tools to feed into our own internal kind of orbital assessment procedures as well. So it's an assessment process. So just using that input, saying here's another way to look at the problem essentially from a slightly different angle that we were used to, kind of can combine and make us all the more effective in accessing those customer requests and being able to fulfill future demand at different orbits and with different constellations. And I'd just like to add that, space is hard, so it's really encouraging to see the interest and enthusiasm that students like Drew and Avni have, especially as they're transitioning into the industry and being able to bring all that energy and new ideas and innovation with them as they enter into the workforce. So it was a pleasure working with them.
Well, thank you for that response. One last question for both of you, Karyn and Guillermo, is how important are partnerships such as the one you did with Virginia Tech, and how important is it for Clios to instill, just grow the young workforce into these new skill sets? So I guess it's a two-part question.
Yeah. Well, for me, I think, a big, I think it's pretty critical, but I think a big part of that sort of need and advantage and necessity of the partnerships is because it affords us the ability, by extension, to look at research options that we just simply in the industry a lot of times don't have time to, because we're having to do the mission as well as learn and innovate at the same time, and so a lot of times actually doing the mission and fulfilling customer demands takes the vast majority of the time, leaving a lot less time for doing things of looking at things in a completely different way or coming up with a completely novel approach that might require a lot more time investment and energy into the research part of it. So partnerships with universities, I think, for me, bring that kind of critical element, saying, well, let's take a sort of maybe a longer view or a completely different view that's more unproven, but potentially could be a lot more, the return on investment could be a lot larger down the road. So it's just that, enabling us to take advantage of that, as well as while we're fulfilling customer needs and the mission and trying to get our satellites, operational in space as well.
A great response. Thank you.
And for me, Adam, as you know, I've always been reaching out from high school on to the students, trying to grow them and encourage them in the STEM areas. And I'm always looking to help them, students, find opportunities that are going to position them for the future. And it was really important for Clios to say, nobody has really done this. We have a very small industry of these commercial RF organizations and companies, and to try to, instead of trying to convert people from other fields, to maybe start growing some of that in the colleges, in the universities, so that it can be taught as a discipline, so that we can learn, because it is such a nascent industry, so that we can learn and get new ideas in quickly and have people graduating who can fit right into that workforce.
No, it's amazing. Seeing the partnership between industry and a collegiate organization trying to build up the young workforce like that. I think there is still somewhat of a stigma of hiring young people because of their inexperience. But what I'm seeing from you both, Andrew and Avni, is that Virginia Tech has a very robust program to get you involved directly while you're studying these things, learning about them, and from a very technical aspect. And right out the door, you two sound like, you do sound like direct hires. Yeah, I mean, yeah, that's incredible. So this is a really awesome success story, not just for Clios and Virginia Tech, but just how growing into the industry should work. So once again, thank you all for joining me for this interview, talking more about the project that you all work together on. And for those that watching Project Geospatial, hopefully you get inspired to learn more about the program at Virginia Tech, learn a little bit more about Clios, and we'll talk to you next time. Thank you very much.